So this is a Git tutorial I wrote for a young PhD student arriving in my team. So this is very basic stuff. But the first question I wanted to know is, like, has anyone never used Git before? And if so, can you please raise your hand? Okay, cool. So I'll assume everybody here has used a bit of Git so that we can maybe move along a bit quicker. So the two main reasons why we will need Git, and I'm going to move quickly on that, is for code versioning and for code sharing. So code versioning is, of course, to have a way to revert to a code state stable or to have reproducibility for a scientific result. The small gotcha is that it doesn't work well with data, so you might need some other type of versioning for the data, or at least big data. The other reason is, of course, code sharing. And this is to work in a team or to work in an open source environment. And the proper way to use Git is, I mean, like the most basic way to use Git is to use it as a command line tool. And those two commands, so git commit and git push, are the usual kind of things you can type in a terminal. How does it work broadly? Git is a tool that keeps track of the state of a code. And the way it does that is it uses commits, engagement in French. And these commits are defined by the user as their code. And when you want to share this code, you have to push all those commits to the distant repository. I didn't say it, but the commits, so the engagement, are the versioning part. So each time you commit a part of the code, you say, I commit to this part of the code being in my state of code. And in practice, what's going to happen is, and I'm sure you've all experienced it, that you need to code with your favorite editor. And the difference is that every time you are happy with the state of your code, you need to commit it. So I say that, like, a rule of thumb is that you should save your code every time you have a line of code or a paragraph. This should be kind of a reflex for everyone, I guess. And you should do it every time you have a working version of your code. And maybe it should be in separate commits because you want to name each commit differently, but it can be also in one commit. I personally push almost every time I commit, but it depends on the connection, and it depends like what is the practice you have. For example, in the pull request, some people don't want to have too many pushes because it might be overwhelming in terms of notifications. So I guess since you've all used Git before, I'll skim through that very quickly. So the way you commit changes is first to stage them. So you stage them using the add keyword and naming the different files that you want after that. So you can use wildcards, or you can use just folders. This is up to you. And then before you stage anything, you should check that you didn't put in the future commits any files that you didn't want, so you didn't stage anything wrong. And this can be done via the git status command. This is very helpful in case you, for example, added a secret or a very big file in your staging, and you don't want to commit that to your code base. Sorry. And then you can commit with a certain message. So a commit is going to be the combination of the code that you added in your code base and this particular message describing the content of that small change, of that code that was added. And the best practice here, and it is not really highlighted in this example, but is to have a very descriptive commit message. And this is to be able to not have, at some point when you want to find the time a bug was introduced in the code base, commit names like fixed bug or fixed typo or removed code. And this is something that has happened to me in a professional context, and it's very annoying to do that and to have to spend like 1 or 2 days just looking for that small commit that changed everything. So after you committed your code, you can push it to a distant repository using the git push command. So push is obviously the keyword to push. And to set the whole distant repository thing up, I think that GitHub can do a better job than me explaining that. So I'll refer you to this link here, and we will not go further into details on that. What I want to spend time on, however, is to explain a little bit how to fix minor mistakes. So I explained that you see, if you want to prevent minor mistakes, you should always use a Git status. But you can revert minor mistakes by using reset, for example, to revert back to an old code state that was working. Or you can, for example, if you want to change the last commit message because it wasn't descriptive enough, or because it didn't contain all the information needed, you can amend that last commit. So this is something that can be done before you push. After you push, it's a bit more complex, especially with secrets or big files, because if you just push another state of the code where the secret isn't there or the big file isn't there, it will still be in the Git history, and that can still be a problem. So either for security reason or for memory reasons. And you need different things to tackle this kind of problems. However, you're going to make mistakes in the Git history, and you probably have already, if you have a lot of experience with Git. I have just 2 tips on how to prevent major mistakes. First is a very simple one, very dumb one. If you're afraid you're going to mess something up, you should copy paste the source code locally in a different location before anything that's very risky with Git. That's what I do when I'm a bit afraid I will mix things up in my own repo. And this is a way to be safe, to be very safe, let's say. Of course, when you do that, you should pay attention that you copy paste everything that you need. This is also something that can go badly. Another way to prevent a big mistake is to create a branch that will serve as a marker of the code in a stable state, or you can also create a tag. However, one thing that you should keep in mind is that in the open source repos, if you have forked it, you cannot really destroy everything in the main repo. And so you can always revert at least to the state of the main team repo. And now I will move on exactly to this open source part, which is the GitHub flow, for open source team projects. And I will describe how, for example, you can contribute to an open source project, like, for example, say the NumPy or scikit-learn or SciPy. So the first thing to do is to, and I will give an illustration of that afterwards, but I will first detail very numerically the different steps that you need to take. So the first step that you need to do is to fork the main project that is making a linked copy of the project, and that is you have a button for that on GitHub. Then you have to set up the forked project locally using git clone. And once you have done that, you can add the main project repository as a distant repository. And now you have 3 different kinds of repositories to take into account. So you have your local repository, which is the code on your machine. You have your distant repository, which is the forked version of the repository, but in the cloud. And then you have the project's distant repository, which is the original project repository, and it's also in the cloud. And now what you can do to add a contribution to the codebase is to create a new branch where you will add your changes corresponding to the features that you're adding or to the bug that you're fixing. And this is the reason why you shouldn't code on master is because master should always be a mirror of the original project. And finally, to end your contribution, once you've added all the things you need for your contribution, you can push the changes of your branch on your distant repository and open a pull request. Thankfully, on GitHub, it's very easy to do and it's pretty well integrated. You will see that in the practical session. So in terms, this GitHub flow, I wanted to illustrate it so that it's a bit more easy to understand the 3 different repos and how they all play together. So originally, you only have an original repo in the cloud with a state of the code, which we're gonna name A, so here. What you do when you fork, when you click on that button on GitHub, is that you create a clone of this repo, still in the cloud, but that is now yours. Then when you clone this repo, you have the same states of the code, but now it's in your local machine and it's still in the master branch. And so it's very important to see that for now, all 3 are in the same code state. And now you want to add your feature. So what you're going to do is you're going to create a branch. So basically in the previous slides, the feature branch didn't really exist, but I wanted to have it just to keep a single view. And when you do git checkout -b feature, you're creating another branch, but with the exact same state of the code. And now you want to, what's going to happen is you're going to code in that branch to add your contribution. So for example, you're going to create a state of the code, which is going to be the state B. For now, it isn't staged, it isn't committed or anything. So it's still something that is separate from A. When you stage it and when you commit it, B becomes the main state of the code for the branch feature. What you're going to do is that you're going to push that branch to your distant repo, but to your fork of the repo. And to do that, you do git push origin feature. The reason I put the set upstream is because the first time that you're going to push a branch, you need to set it upstream so that you don't have to specify the branch name every time after that, and you can just use git push. But this is a small feature. And then you can just open a pull request on the original repo. And this is done by clicking the new pull request button on GitHub. So it's very simple, pretty well integrated, and you just have to say that you want your feature branch to be the comparison for this pull request. Once it's merged, this is the kind of state that you're going to have. So if you wanted to have only one contribution to this particular repo, you could leave it as is. But if you plan on having more contribution to that repo, or if you're actively developing it, you need to update the state of the code in your fork on the branch master and in your local machine as well on the branch master. So what you can do is you can add the remote original repo as another remote repository in your local machine. So this is done by git remote add a name. Most of the time it's called upstream and the address of the original GitHub repository. And then you just have to pull the modifications that are registered on this original repo. So you do git pull upstream master. And finally, to also update the state of your fork in the cloud, you need to push the modifications that happened on the master branch. So all of this is going to be the topic of the practical session that I have planned next. So I'm going to move on quickly to some tips and best practice for Git, but obviously, if you have questions, we can come back to them afterwards, and we will practice in the practical session just after. So some tips and good practice I have for Git. Obviously, this is just coming from me. I'm not an expert. I just have some experience with Git, and this is the kind of things I found have been useful for me to avoid mistakes or to be a bit more efficient. So the first thing I want to advertise is the fact that you should always know what you're committing, and the best way to do that is to always to never to always separate the Git stage and Git commit part. That is, I never use Git add all, or I never use Git commit minus AM. It might be a bit slower, but it makes sure that you never add anything that is not supposed to be there in a commit. And in the long run, it's quite useful to always be sure of what you have in commits. So I said that you could always use wildcards for the staging. And another thing is, as soon as you're comfortable with the Git commands, you should definitely try to use aliases that will be much more efficient for you when you use Git. So typically, Git add can be kind of long to type. So if you use the alias provided by OMyZSH, for example, you can just type GA. It's very convenient, and it shortens a lot all of your Git comments. And this is something I am very happy about, is to have switched to aliases for the Git commands. Obviously, you can use aliases for a variety of different things, but I think that Git is where you get the most efficiency. Another good practice, but I think it's valid for a lot of different things, is of course to use a Stack Overflow as soon as you make a mistake. And I'm repeating this for the commit message, is to never try to gain time on commit messages, because one day it will come to bite you in the ass if you do. So you should never have a C or a list of bug fixes as commit messages in your Git history. It is very painful to navigate through that. So I don't know if I should have a question time right now before the practical session, if some things aren't clear. I guess we can just before moving on to the practical session. So if anyone has question, please unmute your mic and ask me. Okay, I guess since no one has any particular question, we can move on to the practical session. So I sent you the link on Slack, sorry, in the Learning Start channel, and so we can try to all do a simple contribution to this toy repository. And obviously the contribution, I have a suggestion of a contribution in the Git repository tutorial. But if you want to have a better contribution to this, please don't hesitate to do it. So maybe what I can do is I can try to share my whole screen. I don't know if it's possible. I don't know if it's possible. Anyway, so to participate in the practical session, it's going to be very simple. The first thing you have to do is to go on the GitHub repository, which is hosted in my account, and it's called Git Tuto. And in this repository, you're going to see a fork option here. So obviously I can't fork it because it's my own repository, but if you click on it, you should be able to see your account or the different accounts that you own, and you can fork it on the account that's best suited for this this particular tutorial session. And the different steps of the tutorial are listed here in the README. So like I said, you should fork this repository first, and then once you have forked it, you can clone it with this command to type in your terminal in the location you want. So I don't know if I should try to wait for everyone to have done these steps. Maybe the best option is to for me to do these steps as well in a terminal. So I will try to do that. Okay, so I'm going to go to my workspace. And here, like we said,
can I ask something? Sorry, I mean, do I have to put necessarily also this first thing before? I mean, I just did the git clone with the git with the git address, which is in my after I forked in my that I copy, right? When I do, like, if I go to my page now, I see the one I forked. So in clone, I have the HTTPS address, and so I just do git clone with that. I don't understand
yes, okay.
but you wrote a command which is slightly different, so I was wondering if there was any reason for that I'm missing.
Sure, I can understand that. So the difference is that the way you're going to clone it is you're going to clone it using HTTPS, and the way I suggested to clone it is to use SSH. So to use the SSH cloning, you need to set up SSH for GitHub. So that is something that is well documented on GitHub. I think that the difference when you use HTTPS and when you use SSH is that for HTTPS, you're going to have most of the time to type your password when you're doing Git operations that need private information, or for example, if you're accessing a private repo or something of the sort. Whereas for SSH, you don't need to do it because you have SSH authentication happening. I think it's the main difference. I'm not really aware of other differences that might happen in between SSH and HTTPS. I think, and this is a field where I'm not comfortable at all, but I think that SSH is a bit less secure than HTTPS, but that's not something I'm very well aware of, so I couldn't tell you exactly the difference. Okay. I just know that.
So it's fine if I keep doing it just with the HTTPS. I mean, there's
yeah, I think it's completely up to you. Yeah. So after you cloned it, you might want to add now the original project as a distant repo, but it's not something that is completely mandatory. I just like to do it in the first place because I figured that I might want to contribute a bit more to the repo, but it's completely up to you. Then you need to go to, so in my case, I already have the Git tutorial, so I don't need to clone it. So I just need to cd into it. And now I'm going to go back to master. And when I'm on master, I can create a new branch. So a new branch is going to be something like, for example, your name or your pseudonym or any type of things that you want to contribute to this project. In your particular case, if you want to take a bit more advanced tutorial, you can try and add a Python function to this Git repository. So if you look at the tree architecture, so sorry, I'm going to put a little bit less. You can see that the Git repository is composed of a README, a participants.csv, which is just the list of all the participants, and a CI tutorial folder. So if you want to participate in the CI tutorial, you can add a function in the simple functions folder, and add a corresponding test, corresponding unit test in the test. So you already have an example. Normally, I wrote a simple function for me. Sorry, we don't see it. And you should be able to simply add your own function. So, sorry. I am surprised it's missing. So maybe something is not right. Oh yeah, I hadn't pulled before, sorry. So that's why the simple function was missing. But as you can see, I already have a function called Zach function, so you can just type in your own, I don't know, function that is going to just implement the addition or just a multiplication. It's really up to you. And if you add a unit test for it, it will also be part of the continuous integration for this repo. And the continuous integration is quite handy because it allows you to test the state of your code continuously while adding features to it. And so it's very convenient when you have an open source project because you don't want to every time manually test your project. So having a tool that will do this manual, that will do this testing automatically, and that will do it continuously while adding features is very convenient. In this case, I chose to use Travis just because I'm used to it, and it's very simple to set up. You can see that it's just Travis, sorry. It's just a travis.yaml file that I put here in the root of my repository. And it will perform just a simple PyTest run over the function that you might have implemented. If you don't want to take part in the CI tutorial, obviously you can just put your name in the participants CSV, and that should be fine for you. However, understanding the continuous integration might be useful because it's something that is instrumental in having projects that can last and that can have a lot of contributions to them. So I think I saw that a lot of you already had cloned, already had forked, sorry, the repo. So there should be a lot of pull requests coming in soon, I guess. Yeah, we already have Santi participated to the. Okay, so what I'm going to do is I'm going to ask Santi to do a minor nitpick. So I'm going to say that Santi has to add a comma so that you see how a typical workflow would be. Obviously, here I'm nitpicking on purpose just because there is nothing really major to add, but it's just so that you see how an interaction might look like on an open source GitHub project. Just as a reminder, I wanted to say that so the first thing I did was to request changes on Santi's PR. It was a very minor nitpick, and it was just for the sake of it. And I wanted to introduce the squash and merge. So there is basically a button. So maybe if there is another pull request coming, I can show you at some point. But basically, there is a button that allows me to squash and merge a pull request instead of just merging it. And it allows you to have a single commit associated to a pull request. And you can see that in your Git log. So for example, if now you look at your Git log, you will see that there is a single commit. If you pull the master branch from a sim, you will see that there is a single commit associated to Santi's PR. And to see that, you need to, of course, pull the upstream version. So this is done by, for example, doing a git pull upstream master. And I think that's all I wanted to show. I wanted to show the squash and merge button, which is here. But obviously now I cannot squash and merge because this branch has a conflict with the current version of master, and this is because Toby has submitted a pull request at about the same time as Santiago, and so now the change that Tobias wants to introduce is conflicting with the change that Santiago has introduced. So to tackle this problem, Tobias, what you need to do is a bit complex, and I didn't put it in the README because I didn't think that everybody would do it in the same time. This is something that I took from an old tutorial. Maybe I can explain on in the terminal or no. I will explain as a comment. So what you need to do is you need to go back to the master branch locally. And to do that, you need to do git checkout master. Then you need to pull the current branch, the current version of the code. So to do that, and this is done by simply doing a git pull upstream master. So this will pull the changes introduced by Santiago, and now you can revert back to your own branch. And here, what you need to do is you need to merge back the changes that have happened on master on your current feature branch. And so this is done simply by doing a git merge master. So here there are different opinions. Some people think that it's better to do a rebase. Some people think that it's better to do a merge. Honestly, I don't have a strong opinion on this. So if anyone has, I'm happy to hear it. And once you have merged master and you have solved the conflict of bias, you can just push this new version of the code to the distant repository, and this will update the PR, and I will be able to merge it. Okay, so other than this conflict handling, I don't really have anything else to share. So if you have any question, now is a second good time to ask them.